All right, so this is the review for multiple choice spring semester of 2019. And on this slide file that we're going to be missing the second page again, but we are going to kind of insert some problems to make up for the fact that we're missing a few questions. So number one, we're going to subtract these functions. If you remember on your post-test, some of you got in trouble on this question because you didn't subtract properly. And remember, it is going to be a multiple choice. So I didn't put choices on your review because it takes a lot of effort and I just didn't have time to do that. So for now, you're just going to manually answer it and then hope for the best. But you're going to check on the answer key, of course. We have posted the answer key. So what I would suggest you guys do on this question to ensure that you get it right, distribute that negative sign and rewrite the polynomial without the parentheses. So x squared plus 5x minus 7, and then this becomes a minus 3x to the third. This becomes a minus 6x, and this will become, carefully, plus 7 on the end. So when you go to collect all your like terms, usually your teachers put your answers in standard form order. This would not be an exception to that. So standard form would start with this cubic term, so negative 3x to the third. And then, let's see, there's a quadratic term right here, plus x squared. Let's go ahead and collect these linear terms. 5x minus 6x is a minus 1x. And then something kind of awesome happens on the constants. What happens to your 7s? They just cancel out. So the final answer you'd be looking for would be negative 3x to the third plus x squared minus x. So I think that's the way you need to go. Remember, guys, you get 80 minutes to do this test. So you definitely have time to distribute a negative and rewrite it. Plenty of time on this test. Profit function. Okay, some of us forgot how to find profit. The idea is that you take your revenue and you subtract your cost. So what I would write down in my notes here as I'm studying is I would put the word cost in parentheses because this is where the mistake occurs for most of you when you make a mistake on this question, if you make a mistake. So the revenue function is this guy right here. So I'm going to replace that with a 3.5x. I'm going to put down a subtraction sign with parentheses. And the cost function is this. So I'm going to replace cost with 0.55x plus 15. So I'm glad that we remembered to put the subtraction outside of the parentheses because now I'm going to have that same issue as the first question where I have to distribute the subtraction to everybody. And you get 3.5x minus 0.55x. This last term, though, also becomes a minus 15. So for your multiple choice answers, they're going to want a simplified version of this. So go ahead and collect your like terms here. Oh gosh. Is that 2.95? Someone double check that for me. Awesome. 2.95x. And then remember we distributed this negative, so it's a minus 15. Do you think I would put a 2.95x plus 15? Yes, I would. As a choice, I mean, as a teacher. As an evil, mean teacher. Yes, I would do that. So I'm trying to catch the kid who doesn't know to subtract all the way through. So don't be that kid, I guess. All right, just so I don't have to keep flipping slides, would you guys mind looking over here at number 8? I know we're out of order, but just look at number 8. I want to know the remainder when we divide these two. So if you think back to when we divided things, your choices are long division and synthetic division. So if memory serves me correct, most of you thought that synthetic division was a lot easier. I agree. So you start with your divisor, but if I'm setting up synthetic division, what goes in the box if we're dividing by x minus 3? Positive 3. Very good. So some of you thought it as the opposite to that. It's the solution to the factor. And then you're going to set up your coefficients and make sure that you're not missing any coefficients. Like if there's a missing quadratic, you got to put a 0 placeholder. So it goes cubic, squared, first power, constant. So we're not missing anything. I'm just going to write down my coefficients. 3, negative 13, 18, and negative 18. And this question, they want to know what the remainder is. So all they need from you is to do your work until you can find this number down here. Once you find that number, that is your remainder and we'll be done. So we get this party started, remember, by bringing down our first term, our first coefficient. And then Mrs. Meyer used to always teach you guys that when you're below the line, you multiply. When you're above the line, you add them up. So 3 times 3 is a 9. And then add these up, and you get a negative 4. Negative 4 times 3 is a negative 12. And when you add these up, you get a 6. And then 6 times 3 is a 18. Hello. And then down here, negative 18 plus 18 is a 0. So when it says, what is the remainder? Your answer is 0. 0. Whoops. So we're going to use a similar skill here on the next question. Here it flat out says to use synthetic division to find the quotient, so they actually want you to come up with the answer to the division question. We'll get there in a moment. It does say to use synthetic division. However, if you're just a huge fan of long division, would I know? If you secretly use long division? No. The reason I wrote use synthetic division on this question is because for a lot of kids, if I just said to divide, their brain goes straight to long division, and that usually has a negative thought because they don't like it. So I didn't want you to get frustrated on your final that you had to do long division, because we sure don't. I would suggest you guys use synthetic division instead of long division. So the solution to your divisor here is a negative 2. But please be very careful here, guys, when lining up your coefficients. Your coefficients, do you notice how they're missing a quadratic? There's like a nothing x squared that should belong right there. So you have to include that in your lineup here. So you have 1x to the third, you have no x squareds, you have negative 14x's, and then you have a positive 8 for your last number. So I do want to warn you, there's a question like this on your test where you have to remember to put a placeholder in the missing part. Alright, so same as the last question, you bring down this 1 to get this started, and then if you're below the line, you multiply, and if you're above the line, you're adding them up. So 1 times negative 2 is negative 2. And then add this column up and you get negative 2. Negative 2 times negative 2 is 4. Add these up and you get negative 10. And then negative 10 times negative 2 is a positive 20. And we add those up and we get 28. So again, this last number here, this is your remainder. So if I was on a multiple choice test, maybe I wouldn't have to do a ton more work because I'd look through my choices and look for the one that has a 28 remainder. But what if something like more than one choice had a 28 remainder? So remember, guys, you take your lead term, divide it by this lead term. So if you started with an x to the third and you divided it by an x to the first, that means this guy right here must be a 1x squared. And then this next one would be a minus 2x. This is your constant of minus 10. And then just for funsies, who remembers what we do with remainders? We write them as fractions because they're still stuck in the division. What are they still divided by? Yeah, whatever this was that I scribbled out by accident. X plus 2, very good. So technically this is the proper answer, but this being a multiple choice test, I have a feeling you would have deduced your way to the right answer way before that. Do you suppose if I forgot to put a 0 in the placeholder and I just kind of went to town doing synthetic division, the answer that I get, do you think my teacher would put as a choice? Oh yeah, she would. Because that's the number 1 mistake in that question, okay? By the way, the number 2 mistake is the kid who puts the wrong sign right here. They put a positive 2 instead of a negative 2. So start getting a little paranoid on your test, I guess is my motto here. Let's talk about how we multiply two polynomials together. We have the polynomial for f and the polynomial for g, and they want you to multiply them together. Well, a lot of kids just do this. And they don't usually get it right because they forgot that polynomials, when you multiply them together, have quite a bit of distribution that you have to handle. So essentially this is a distribution question. You guys often call these foiling questions. So the 3x gets multiplied by the x and the 5. So that gives us 3x squared plus 5x. And then you're going to do the same idea with the minus 3 here. We're going to distribute the minus 3 to here and here. So you have a minus 3x and then a minus 15. And then simplified final answer that we would come up with is 3x squared plus 2x minus 15. Did I mess up? What'd I do? Yeah, it is. Back up. Like I said, this is a plus 15x. Oh, man. So what does that give me, a 12? Everything else okay? Oh, good news. Good catch. Okay. You do get a formula sheet on this test. I didn't want to give this to you ahead of time, though, because I didn't want to have to give everyone a brand new copy during finals. So part of your formula sheet will be the factoring flowchart. You'll get the factoring flowchart. So this next question, because it is two terms, if I look at my factoring flowchart, I move down off of the common term thing. That's not an issue here. If it's two terms, that means it's one of my special patterns. And this one is the difference of two cubes. So what I would do on my test, and you can write all over your test when you get it, guys. It's not gonna be one of those don't write on these tests. I would write down the pattern straight off of my flowchart. So the factoring side of the pattern is a minus b times a squared plus ab plus b squared. And all we need to figure out now is who is this a and who is this b that they're talking about. So remember, the way you find a and b is you take the cube root of each of these terms. So the cube root of x to the third is just x. And the cube root of 27, not negative 27, but 27, is a 3. Do you guys remember on your calculators you can do the cube root under the math key? Or some of you just think really hard about what the cube root of 27 is. And there's also a listing of numbers on the bottom of your factoring flowchart. So plugging those numbers in where they belong. And remember, guys, multiple choice pattern. So if you're looking at your patterns going, oh, that one doesn't match the pattern, just cross it off and deduce your way to the right answer. You're going to get an x minus 3, and then x squared. Oh, my colors are getting backwards. Try again. X squared plus 3x. And then on the end here, instead of calling it 3 squared, we would appreciate if you guys would call that 9. Remember, it's a matching, multiple choice thing. So you're going to look at which answer is proper. Easiest way to deduce on those questions is to look at the signs and go, oh, if it's a difference of cubes, the signs are supposed to go minus plus plus. So anything that doesn't follow that order, just cross it off from your choices. Okay, switch over to number 10 and 11 so I don't have to change slides again. 10 is a vocab question. The degree, by definition, is the largest exponent. So if you look carefully in this question, who is the largest exponent? That'd be a 4. I don't even ask you what that means. I just say, do you know what the degree is? And it's a 4. So this next question is going to be an end behavior question. Again, it's multiple choice, so you have to look carefully because these are kind of hard to look at in multiple choice. But it's going to be a bunch of these. So end behavior. This means left, and this means right. So if I was not sure what this looked like, I should see you guys grabbing your calculator and graphing it, like putting this function into y equals. Well, little heads up here, guys, for the sake of time. The ends do this. It's like a weird W looking thing, and then the ends go up, up. So how do you say up? You just say infinity. Good. So I'll be honest, that question written in multiple choice form, for me, it's like a dyslexic's worst nightmare, because yeah, that's a lot of things to look at. Imagine having 4 choices that look almost identical to this, but I randomly switch out a negative for a positive or something goofy. So what I do on that question is I either think about what it looks like or I graph it. I make sure that nothing weird is happening on the left side, right side business. And then I just say, okay, well, if both ends are going up, up, I'm looking for up, up over here. And I start crossing off things that don't match that description. I don't like that question as a multiple choice style question, but it's the kind of test we're giving you, so I apologize. Okay, so this is where I'm missing a whole bunch of stuff. So could you guys flip to the next page? Oh no, did I miss a whole question again? 12 and 13? Okay, never mind, stay on the front. Look at number 12. So 12 says, identify the relative minimum value of this function. And does it, what does the power say? Does it say to the 4th power? 2x to the 4th power? Okay, cool. I need you guys to get this typed in your calculator. And I will do the same. plus 5? Okay. And then depending on my window, this window might work, it might not. Okay, it's good. They want me to find the relative minimum, which means you need to figure out the lowest point in the graph. So we need to figure out how low this guy is. And I know with it being multiple choice, some of us are looking at it going, well, I can kind of guess what the minimum is. That's actually probably a great way to do this question on the multiple choice test next time you test. What were you going to say, kiddo? Were you going to answer it for me? Yeah. Oh, well, hold on. So to find the minimum, if you want to find it exactly on your calculator, which command in the second choice menu do I pull up? The minimum. So the minimum one. So when it says left bound, right bound, they want you to drag it to the left and to the right of this little dip. So, you know me, I have to hop because my thing is too slow. So I'm going to go -2 is on the left side of it, 0 is on the right side of it. Careful here though, guys. Which part of the ordered pair is the value for the function? The y value. Very good. So this number right here, the height, is what I want. Okay, pen, you're going to work today? No? Not today. Okay, there we go. You need to make sure you're giving me this number. Okay? Not the x value, but the y value. They want the value for the function. Do you think I would be so cruel as to put the x value as a choice? And the answer is yes, I am. Okay, I'm going to write a few notes here for my slide readers. I forgot what it looked like. I know it was a W. Okay. So it looked something like this. And you found this guy. What was it? 2.97? Oh, cool. All right, let's look at number 13. They want the domain and the range for an exponential function. So you are welcome to graph this. There's absolutely nothing wrong with grabbing your graphing calculator and graphing this one. In fact, I encourage it. I think sometimes you guys look at the functions and on a test you're a little stressed out and you make some weird assumptions that don't really work. But for those of us who are up for a challenge today on a Tuesday, the base is a 4, which means you're looking at an exponential growth. There is no vertical shift. There's plus nothing off to the side. So the asymptote is still going to be at 0. So you're going to see an exponential growth that's going up pretty stinking quickly, but that doesn't really matter because the domain and range don't really change much. For instance, what's the domain? It's always negative infinity to infinity for exponentials. The range, however, is going to start, if it's not reflected, it's going to start at the asymptote. So for us, with this being shifted up nothing, the range is going to start at 0 and go up to infinity. Okay? That's the sort of thinking that you can do ahead of time before you graph it. But what I think you guys have plenty of time to do is to actually take your y equals screen and graph that function and confirm, yes, I am pretty sure that the domain is negative a to infinity and the range is 0 to infinity. Do you think I would be so evil as to put a choice where it's backwards? Probably, because that's a big common mistake that I want to catch you on. Sorry. All right, let's take a look at the next page now. Oh, wait, no, there's one more I skipped. 2 more. Am I missing a whole page? What's happening? Did I do number 5? Oh my gosh. I didn't do like anything. Did I skip all of that on my video too? None of you watched it yet, so you don't know. Okay, well anyways, back up. Stay in the front with me. Let's look at number 5. It says the 5 properties of inverses. Okay, here's what they are in a nutshell. Number 1, the x and y switch. These are not in any particular order. So if you're thinking like a teacher and you're like, how is she going to ask me this question? Well, it's probably going to be one of those, which of the following is true? And then maybe one of the choices says all of the above. Keep that in mind. Okay, so domain and range switch then. There's a note about it being reflections over the line y equals x. So when you graph an inverse, they're like diagonally reflective of each other. There's another property about if the inverse if the function passes the horizontal line test, then the inverse is a function. I'm doing some heavy abbreviation here, guys. So if I asked you a question and it said, which of the following is a property of an inverse? And it listed number 1, and number 2, and number 3. What do you think shows up later on in your choices? All of the above is probably going to be a choice, huh? Yes, ma'am. Function passes horizontal line test, then the inverse is a function. All right, let's get, oops, insert page. Who did I leave off? We did 12, 13, I need 6 and 7 still. All right, sorry about that. All right, number 6, what is the complete factorization of that polynomial? Well, again, you have your factoring flowchart, but the fact that they wrote the word complete makes me a little nervous. So there's no common factor. We're going to use one of our special patterns, and we're going to start by using the difference of squares. And this kind of reminds me of one of our questions that was on the post test, where we factored one time, and then we had to factor again. This is going to be one of those. So the way the difference of squares works is you take the square root of each term. So that would be x squared and x squared, and then a 16 and a 16, and one's a plus and one's a minus. Now, I'm going to warn you guys, if this was the question on the test, this would be a choice. But why is this not the correct choice? You have to keep going. Yes, there's more. This is another difference of squares. So this factors again into x and x, and then a plus 4 and a minus 4. Does this first one factor, though? No. The sum of squares does not factor. So that's the choice that I'm going to be looking for, and I'm going to be very aware that my teacher's going to try to trick me on that one by putting an incomplete factorization, okay? Those of you who just like to foil things back together and go, magically it works, doesn't mean it was the complete factorization, so be careful on that question. All right, and then number 7 is kind of weirdly worded for this review, but it's going to be very easy to do on the test. On the test, number 7 is going to say, which of the following is a cubic function? Well, what are you looking for when you have a cubic function? If you want to use a vocab word. You're looking for x to the 3rd power. I don't care what follows that as long as nothing has anything bigger than a 3rd power. You could put nothing after it. That is a cubic function right there. If you want to get creative, you could say plus 4x minus 2. That's a cubic. You could put a lot of things after it, just don't go bigger than the 3rd power for the degree. Yes. Was it your, oh, you don't question? Okay. Never mind. All right, so now I'm missing a bunch of questions I heard. Back up. Alrighty, so number 14. And these actually do have multiple choice options. So you can kind of get a feel for how to be a smart test taker on this page. It says, which of the following represents a decay? What are you looking for? Thank you. In a function here, for this to be considered a decay. All right, so this base, this number b, has to be less than 1. Technically speaking, it has to be between 0 and 1. So numbers like 1/3, 2/3, 3/4. So which choice here looks like it has a base that's smaller than 1? Choice D, very good. Because the base is 1/3, which is smaller than 1. You do not have to explain yourself on this question on the test. It's just going to be a simply, just like this, a multiple choice question, okay? All right, this next one, you're going to want to use your calculator, and I do provide you this formula. We have continual growth, which is the PERT formula. So remember, E is a number on your calculator, and then up in his exponent, you have R times T power. So in this question, you're going to invest $2,000, so that's the P. You're going to multiply it by the number E, but then up in the exponent, it's being raised to the R times T power. So if R is 4%, be careful guys, how do you write 4%? 0.04, good. So it's 0.04, and then you're going to multiply that by how many years you leave your money, and if you keep reading, it says 8 years. So in your home screen of your calculator, I need you to type this. And for Pete's sake, guys, could you use some common sense on this question? You're investing $2,000. You're going to leave it in the bank for 8 years. Can you look at your answer choices and tell me if something here seems a little crazy? Yeah, so one of your choices is like $50,000 or something. Like, that doesn't seem like a reasonable amount of money, guys. So keep that in mind when you're looking at your test. If there's some amount that's less than $2,000, like, that doesn't make any sense either. So keep that in mind. The answer on this one comes out to choice C, I believe, which is 2754.26. Whew, kind of crossed off my answer. My bad. So you do not have to memorize that formula. It will be given to you right there on the question. Same thing with the next question, whoops, where it's the hotel price question. Again, I'm giving you a formula, but you do have to kind of know how to use this one because the formula says it's a times 1 plus or minus r to the t power. So this is a question where it says in 1980 the hotel room costs $48. So that's what we put in place of the original amount. And then because it's going to increase, you're going to use the plus version of this formula, 1 plus r. So 5.1% is the r. Someone help me with the decimal conversion on that. What is that? 0.051, right? You can divide it by 100 if you're not sure. And then if I keep reading, it does say find the hotel price in 2012. So this is the price in 1980. And then we're going to 2012. So how many years are we talking here, guys? About 32 years. So this time they want you to compute it for 32 years. You're going to be on the home screen of your calculator. And again, common sense, guys. This is the cost of a hotel room. So I don't know if that $2 million one makes any sense, huh? Probably not. The one that makes sense and also comes out on my calculator is $235.79. So far, so good? Okay. 17. 17 is a rewriting question. And you will be given a formula on your formula sheet that says this. It'll say log base b of x equals y. And then it'll say b to the y equals x. So that's the conversion for how to go from log to exponential. If you would like to use that formula to get this one right, you are more than welcome to. So the question that you're given on number 17 says log base 3 of 81 equals x. So it's a little confusing because they used x in the formula, but it's not the same x here. So if that really bothers you, you can change x out for something else. Like sometimes we use n there. So if you try to rewrite this one, it would say your base, which is 3, to the x power equals 81. And remember, it's multiple choice. So when you look down at your choices, you go, well, 3 to the 1,000th power doesn't make any sort of sense. But 3 to the 4th power makes a lot of sense. You see choice B says it's 4. So that's a great way to get that question right. The other option, if you guys want to memorize this, you can use what's called the change of base. That's where you type the log of the larger number, this thing over here. So log of 81 divided by the log of the base. So if you have a weird logarithm base that you can't evaluate on your calculator, like log base 3, you can just type this on your calculator, and that's another way to get the number 4. Just make sure you know how to type it, guys. You have to stop your parenthesis after each logarithm. So log 81, stop it, divided by log of 3. Now, the follow-up question, number 18. I would use that rewrite formula on my formula sheet if you were getting a little stuck here on number 18. So for number 18, the question is log base 2 of x plus 7 equals, what does it say, 5? And they want you to rewrite this in exponential form. So that's exactly what we did the first time we attempted this question. We said, who's your base? Well, your base is a, whoops, 2. I was supposed to use blue there. Blue, 2. And then you raise it to the answer power. And it equals whatever was in the logarithm. And that's all they wanted you to do on that question, guys. They don't even want you to solve it. They just say, take this logarithm statement and rewrite it as an exponential statement. And then walk away. Okay. 19. I love question 19 because it's so easy once you get the hang of it. 19 is kind of a, it's almost a vocabulary question at its essence. It says, what's the inverse of this? Well, guys, the inverse to an exponential function is a logarithm. So if I'm trying to find an inverse to a base 6 exponential, that means his inverse would be a base 6 logarithm. That's all I need you to do on that question, is to understand that the inverse to an exponential function is a logarithm who has the same base. So like a follow-up question here, guys, not anywhere on your notes or on your review packet here. Who could tell me the inverse to that one? Ooh, yes, go ahead. The other one. Natural log, very good. Very good. So natural log is a logarithm base E. Yep, very good. So another question. 2 to the x power, who's his inverse? Log base dos, yeah. So that should be a very quick question when you hit it on the test. Okay. All right, finally, I found some review I actually have pictures of. There we go. Okay, so let's take a look at solving this exponential equation. We're going to need to use a logarithm, but just not yet. So first things first, I need you to subtract a 4 from both sides, and you have e to the x equals 19. Now, I have to apply a logarithm or a natural logarithm. Which one would be brilliant in this question? A natural logarithm, because it cancels over here on the left side. And you get x equals the natural log of 19, which is something. 2.94? And yeah, you're going to need a calculator to be able to type that one in, but same idea. All right, I'm going to move down the screen. We're going to expand this logarithm, and you start expanding them by realizing if there's a division. Do you remember how we split a division? Becomes a subtraction. So log of y squared z minus log of a. But guys, that's not done, because inside of this logarithm right here, you have more splitting to do. Okay, I'm going to need to take my work down here. So when you split up a multiplication where it's y squared times z, that becomes log plus log. So this is now log of y squared plus log of z, and then this minus log of a just kind of keeps coming along. And that's still not done, because to be fully expanded, any exponents then have to come down. Now, I know for some of you it's been a very long time since we saw a question like this, but when we did do this and you guys took a test, you did very, very well. So what I want to remind you about is that this question is a multiple choice question. So even though, yes, it took us 3 like algebraic steps to show the expansion, if those steps happen in your head, and you can look at the choices and figure it out that way, that's great. That just means you have a really good understanding about these properties. So now I'm wondering if you could condense it back together a little quicker. So let's throw these logarithms back together into one logarithm. They're going to be a base 5 logarithm still. So I think about what happens now, guys. This exponent comes back up to his logarithm, and so does this one. So this becomes x to the 7th. And then instead of dividing the logarithm, if I smush it back together, oh, sorry, I said it. Instead of subtracting the logarithm, it becomes a dividing, and this is now a y to the 4th. So I personally feel like condensing is a lot easier to like throw together in your head. You can do them in stages, but again, guys, it's multiple choice. So if you know it's going to condense, what did I screw up now? Did I mess up something? Oh, it's not the same base. That's a typo. This is supposed to be a 5 as well. I'm sorry about that. That should not happen on your test, I hope. If it does, I apologize. Okay, I don't have a lot of room for 23, but that's okay. It's not going to take much. You're supposed to exponentiate. Who's the base of a natural log again? It's a base e. So if you shove an e underneath both sides of this question, boom, gone, gone. Now we have a really easy question to answer. So 4x minus 18 equals x plus 3. I'm going to subtract x and get 3x. I'm going to add 18 and get 21. Boom, you get x equals 7. Walk away. Okay, so I don't have to change my slides up. Okay, here's what I'm going to do, because we have about like 3 minutes left or 5 minutes left in class. I'm going to get as far as we can here in this class. I'm going to pause the video, and then during my planning or whatever, I'll finish the recording if you guys need to see me going over the rest of them. But let's see how far we can get in the next few minutes. So what is the quotient? We got some factoring and some flipping to do here. So because this is a division sign, we're going to change this to multiplication by flipping. The first fraction, however, does not change. Alright, so this denominator is now going to be up in the numerator here, and it's going to factor into x plus 8 times x minus 2. And then this now numerator gets flipped to the denominator, and it's, let's see, x, oh, this is gross, x plus 3 times x minus 2. And we do have some x minus 2's canceling. However, I don't think anything else cancels. Do these x plus 8's cancel? No, they do not. So you can just leave them factored as x plus 8 times x plus 8 over x plus 3. What would be a shorthand way to say that, though? X plus 8 squared. Yeah, that would be a shortcut. So I think you'll see on your test that more stuff cancels than that. I think this is probably a teacher typo. We wanted stuff to cancel and it didn't cancel. Whoopsies. All right, this next question, all I need from you is what's the common denominator? What's the least common denominator? So you need x plus 3. What else do you need? And x minus 5. Boom. That's all they want from you. They don't even want you to actually get it. They just want you to let me know, do you know what that means? Now this next one, you do have to get the common denominator. Notice how they put parentheses around the x squared minus 16. They're trying to help you, like, remember you're supposed to factor that. So this is x plus 4 times x minus 4. Which, if I think about common denominators, that's going to be my common denominator on this question. So this guy over here, he's missing the x plus 4. Sorry, I didn't leave you a lot of room here, did I? Alright, so good news. I have the denominator. I'm not going to do any more work on that part. Bad news is my numerator is not quite ready. Got to distribute a little bit. So the 6x plus 1 I'm going to leave. But then there's a plus sign right here. This 4 gets distributed in. So it's plus 4x plus 16. And then clean everything up. So up top here, we're going to have, let's see, 10x plus 17. Over x plus 4 times x minus 4. There's our final answer. And again, guys, it's multiple choice. So if you notice, like, oh man, that one doesn't even have the right common denominator, then probably don't investigate that one any further. All right. This question here should be a nice easy one on our calculator, except we are going to have to use our table. So just a reminder, we're going to go to y equals and we're going to program. It doesn't say how much money to invest, so you guys get to just make it up. How much money do you want to invest? $100. Sounds good to me. So $100. And then 1 plus, careful with your R, guys. The R is, as a decimal, it's 0.035. And then it's compounded monthly. So the N is a 12. And then up in the exponent, that 12 shows up again. But the question is how many years? So that's actually what I don't know. So we're going to leave that as an X. This gets typed into Y1. And then on our table, we're going to go look for We want our money to triple, right? So I need to go look for $300 on my table. Guys, I just need an approximate answer from you because it's multiple choice. So you're going to be like, oh, well, that one. 27-ish here. I don't know what it comes out to. Okay. I'm going to continue recording this, so stay tuned. Okay, so over to question number 30. We are supposed to be defining the excluded values. So remember, they don't actually want you to do much work here, guys. Just tell me what x cannot equal. And in order to figure that out, you just kindly look at your denominators. So there will be a choice. Remember, it's multiple choice. There will be a choice where it says x can't be -5. Like that might be choice A. Is that going to be the correct selection? No, because later on in your choices, maybe down here at choice C, you're going to see x cannot equal plus and minus 5. That is the one you want to choose. So make sure you look through all your choices that it can't be +5 nor can it be -5 because of this factor right here. All right, this next one, they want me to solve it and check for extraneous solutions. That's a very scary looking phrase, but that just means make sure that it doesn't give you a divide by 0. Because this is a proportion, you guys can think of it as a cross multiplication problem. There's nothing wrong with doing it that way, which is I think how most of you do this question. So if you do it like this, don't tell me butterfly. Oh, I can't read that anymore. All right, it says 5 times x minus 1 equals 3 times 2x plus 4. Notice how I haven't actually done any distribution yet because I don't want to forget to do all of it. Now I will distribute the 5 and I will distribute the 3. So 5x minus 5 equals 6x plus 12. And then we solve. So -5 minus 12, that comes out to a -17, which is x. Ta-da! Now, I kind of crossed off half my problem. If I go back and I think about, okay, is -17 going to give me a problem when I plug it in for my x in either of my denominators? No, because the only time it would give me a problem is if it ended up being a divide by 0, which that won't happen here. So the question on your test will be very comparable to that one, I guess, is the moral of the story. So look over to 25 now. I want you to simplify this monomial question. And the way we look at these questions is we think about, okay, well, what happens when I smush them together? So I smush the numerators together, and I get a 32x to the 6th power, because you can add up these x's, and then y to the 6th power. And then do that same thing with the denominator. Let's smush those together. So 6... And then x to the -2 is the next one I'm going to write down, so it lines up with the other x term. And then y to the 7th. And clearly that's not simplified, so we've got to keep going. So next thing I want to do is look at my numerators, and I want to reduce that coefficient. You can either manually reduce it by dividing each of them by 2, or you can hit math enter here. So it'd be a 16 over a 3. And then what about these x's? Be very careful here. You're supposed to do what with the exponents? You're supposed to subtract them when you're dividing like this. But what happens when you take 6 and you subtract a -2? That becomes a +8. Now some of you said, oh, I just took the -2 and flipped it up to the top. And that's how I got x to the 8th. And I said, great, because that's actually the same thing. Okay. So then how about the y's? You have y to the 6th over y to the 7th. You're supposed to subtract these, which gives you a y to the -1. So I could just write y to the 1st located where? Down in the denominator. Very good. You don't have to put the 1st power on it. You can just call it y. So again, it's going to be multiple choice. And your teacher is many things, but one of the things she's very good at is knowing when you're going to mess up. Sorry. And I'm looking for you. So those of you who called it x to the 4th power, that's going to be a choice. What a stinker. Those of you who put y to the 1st power in the numerator, that'll be a choice, because that's a common mistake, right? Those of you who subtracted the coefficients instead of divided them, that's going to be a choice, so be careful. All right, simplified form. These parentheses on your final, by the way, they indicate factoring. So remember on that one test where I came through and like highlighted everything that had to be factored, and you guys were like, oh, thank you. Well, I can't really do that on your final, but what I could do is throw things in parentheses, which means you have to factor it. So this numerator factors into, watch your signs here, guys, it'd be x minus 7 times x plus 2. That would multiply to negative 14 but add up to negative 5. And then your denominator down here is that difference of squares pattern, so that's an x plus 7 times an x minus 7. And now for the fun part, you get to cross stuff off. So x minus 7s are gone, and that's kind of it. So your numerator is x plus 2. The denominator is x plus 7. Does anything else cancel here? Can I come through and cross off these x's? No, no, no. That would be that thing where we always say is killing kittens. So don't do it. Now this time they do want you to go through and solve and check for extraneous solutions. So just so we get this out of the way, can you guys tell me what the one thing is I can't get as a solution because it'll give me a divide by 0? X can't be negative 5, so keep that in mind as I get to the end of this problem. Alright, denominators, got to knock them all out. So I think x plus 5 is the only denominator I have to distribute through. It's going to cancel in the first fraction, we're going to have to deal with it in the second fraction, and it's going to cancel in the third fraction. So I know these are the questions where some of you like still to this day write it out the long way, and on your final exam I encourage you to do that if you feel like you're going to mess it up, because this is like you either get your point or you don't. So please write it out the long way if you need to, but I'm going to take a bit of a shortcut because I'm a little tight on time. X plus 5 times this fraction, the x plus 5s will cancel, so the only thing you have left is the 3x. In this next fraction, nothing's going to cancel, so you still have the 6, but he's going to have to be multiplied by the x plus 5. And then in that last fraction, the x plus 5s are going to cancel again, leaving you with just a 4. So now I carefully distribute and solve. Go ahead and distribute the 6 now. Oh man, I wrote too big. Alright, so 3x plus 6x plus 30 equals 4. And I'm going to scoop my work down here. So that's a 9x. I'm going to go ahead and subtract the 30 over. So it equals negative 26. And then what do you know? A funky fraction answer like always. Is this the right answer, by the way? That'd be bad if I get to all this and you're like, it's wrong. All right, x equals negative 26 over 9. Leave your answer like that. If your answer is a fraction like this one is, it's going to leave it probably in fraction form for your choices as well. Okay? And then I kind of wrote over number 33, but let's talk. I need to convert 3 pi over 4 radians to degrees. And there will be a little bit of a conversion on your formula sheet that kind of helps you out with this, but maybe you guys remember from our last bit of testing, how do you convert radians back to degrees? Go ahead. See? 180 over pi, very good. So we want the pi's to cross off, which they will. They'll cross cancel here. And you end up with 3/4 times 180, or you can do 3 times 180 divided by 4. It doesn't matter what order you type that in your calculator. Let's see, 45, is it 135? Yeah. Okay. Cool beans. All right, so far so good? Sure. Well, let's talk about some more trig. So again, there's a little piece of your formula sheet that talks to you about trig, and this is one of the formulas you'll see. So the period, how do you calculate the period? It's a little formula, and it's 2 pi divided by b. This number right here inside of the cosine function with the theta, the variable, that's b. So to find the period on this question, that would be 2 pi divided by 4. Well, that's not going to be a choice, guys. I control the way the choices look, and trust me, I wouldn't leave it as 2 pi over 4. What would I call it? Pi over 2. Very good. The next question is another vocab question based on the formula. The amplitude is the absolute value of the number in front. So the amplitude is 5. Very good. And then on the test, it'll be a choice question, multiple choice. It'll say which of the following has a vertical shift of like up 4 or down 4 or whatever. This one, since it's not multiple choice in nature, you got to write me up one. So y equals, I'm just going to make this up, sine of x or theta or whatever. How do you say a midline at 4 instead of at 0? Plus 4. Very good. Beautiful. Okay, that looks like one of those buoy questions. We have the displacement of the boat given to you by this function. And the question is, how many seconds for one complete cycle? They never said the word, but what word are they looking for? Yes, they want to know what the period is. Well, that goes back to that first question we did. How do you find period? Well, it's 2 pi divided by b. So I go back to my formula. My b in this formula is weird. It's a pi. So it's just going to be 2. Now, guys, this is a real-life question, kind of. So if the answer comes out weird, like, oh, your boat bobs every, pi over 4 seconds. That's a weird answer for a real-life question, right? An answer like 2... Oh, I said the wrong thing. This is pi. If the answer comes out to something like 2 seconds, like, yeah, that makes a lot more sense. The boat goes up and down every 2 seconds. Yes, it does. I don't know. Maybe. Okay, so that should be the end of the trig section, and then there's a little bit on probability and experimental design at the end, and you're almost home free. This is the end of the test. So we are rolling a 6-sided number cube. What's the probability that you roll an odd number? So probability, remember, is winners over total. That's how you can think of it. So if I roll a 6-sided number cube, these are the possible outcomes. How many of them are odd? Yeah, 3 of them. Out of how many total possibilities? 6. Better known as? What else could my answer be written as besides 1/2? 0.5. What else? 50%. Those all mean the same thing. So just kind of be flexible in your answer choices. If you have a fraction answer and you notice the teacher only gave decimal answers, you're going to have to kind of figure that out. All right, so since I don't have to keep flipping slides, could you look over at this researcher's question? So we have one group to get a new cold medicine, and we're going to compare them to a group that takes no medicine. What is the group that is not given any medicine? So the one that has no medicine given to them, that's given a placebo. Do you remember that group's called? Control group. Very good. And then the group that does get the medicine, yeah, this is the treatment group. And then I'm looking for a big vocab word here. When you have a study whose sample is very different from the actual population, we call that bias. Very good. Bias. That's the vocab word I'm looking for in that question. They use that a lot on our SAT questions, was like, the sample is bias, the sample is bias. Yeah, big vocab question there. All right, couple more probability things. Of course, our test wouldn't be finished without a chart. The good news is this chart does have totals on it, so that's helpful. So I want the probability of female and junior. So let's get this out of the way. What should be my denominator? The total, 69. Very good. So go find how many people are female juniors. Female junior, these 15 ladies right here. Now, if this was a multiple choice test, which it will be, I did not call it 15 over 69. I can guarantee you that because that's reducible. So one option is if you hit math enter and you get the reduced fraction to this, that's probably what I called it. Was that 5 over 23? Okay. The other possibility is they wrote it as a decimal. So like, what's 5 out of 23 if you just type it? One more time? 0.12? No. 0.22. Okay, gotcha. That makes sense too. So I don't know. I don't remember what version of the answer I gave you on the test, but one of those. Okay, careful here, guys. This is an OR one. So first of all, let's get the denominator out of the way. What denominator are we working out of on an OR? The total, 69. The numerator is where the problem comes in. So what I would like you to do is say, okay, it's either a female or a junior. So total females, total juniors, but I have to subtract some ladies. Those 15 ladies that we counted twice, the female juniors got counted twice. So what does that come out to? Oh boy. 50 out of 69, which does not reduce. So I either left it like this or I gave you a decimal, which is 0.72. Okay. And then my favorite question, female, given junior. So this is a conditional probability question. Since it says given junior, that means the only total you can look at would be your total juniors. How many total juniors do you have in this chart? 26. Very good. So out of these 26 juniors, probability that you were a female, 15. Good. So that's a great answer right there. Or whatever that comes out to as a decimal. Yeah, I don't know either. 0.58? Okay. Hey, thanks. Is there one more? That's it? Oh. I thought there was more. That was just it. All right. Well, good luck.